Dear students, now we are going to see the subject linear integrated circuit and the subject code is EC3451. Under that the topic is symmetry gear. On completion of this symmetry gear, students will be able to explain the operation of symmetry gear. Symmetry gear circuit converts an irregular shaped waveform into a square wave or a pulse. The circuit is known as symmetry gear or a squaring circuit. The input voltage V in trigger the output voltage V0 every time it exceeds a certain voltage level called the upper threshold VUT and lower threshold VLT. The circuit diagram of symmetry gear is shown in figure. This threshold voltage are obtained by using the voltage divider R1 and R2, where the voltage across R1 is feedback to the non-inverting input. When V0 is equal to plus V saturation, the voltage across R1 is called the upper threshold voltage VUT. That is equal to V reference into R1 divided by R1 plus R2 into V saturation divided by R1 plus R2. The output graph of symmetry gear is shown in this figure. As long as Vi is less than the upper threshold, the output remains constant at plus V saturation. When the input greater than the upper threshold voltage, the output regeneratively switches to minus V saturation. When the output equal to minus V saturation, the voltage across R1 is called lower threshold voltage VLT. VLT equal to V reference into R1 by R1 plus R2 minus R2 into V saturation divided by R1 plus R2. The difference between two threshold voltages are called hysteresis width. So VH is equal to VUT minus VLT. VH equal to 2R2 VSAT divided by R1 plus R2. V reference is chosen as 0. Then VUT equal to minus VLT equal to 2R2 VSAT divided by R1 plus R2. If the threshold voltage VUT and VLT are made larger than the input noise voltages, a positive feedback will eliminate the false output transition. Also, the positive feedback, because of its regenerative action, will make the output switch faster between plus V saturation and minus V saturation. The resistance R compensation is the parallel combination of R1 and R2 is used to minimize the offset problems. The comparator with positive feedback is said to exhibit hysteresis, a deadband condition. That is, when the input of the comparator exceeds the upper threshold, its output switches from plus V saturation to minus V saturation and revert to its original state, plus V saturation, when the input goes below the lower threshold voltage. The hysteresis voltage is equal to the difference between upper threshold and the lower threshold voltage. The transfer characteristics of Vi increasing and decreasing, as well as the composite input and output curve is shown in figure. Some of the possible quiz questions is: symmetry gear converts slowly varying signal into a square wave. Thank you.